Hello everyone and welcome to the first video in the series of differential equations and obviously the very first video on this channel. Well, in this course we're gonna discuss differential equation in depth. We're gonna make several videos taking different differential equations from the very basic concepts to the very advanced methods and I'll try my best to explain every detail and every method possible in such challenging topics throughout the course. So we can start now. This lesson will be a kind of introductory lesson. We're gonna see the definition, some concepts, some types of differential equations, and for sure we're gonna practice a little bit with a simple example. So let's kick in. Let's see now what we got. We have the differential equations. Well, from its name, we can we can learn that it is actually an equation, right? We know the normal algebraic equation, like let's say we have 2x plus 2 equals 6. Well, let me just reduce the thickness a little bit. Okay, this is a normal algebraic equation, right? Easy to solve. We have 2x plus 2 equals 6. We can solve this by subtracting 2 from each side, which comes out to be 2x equals 4. So x equals 2. This is a solution of this equation. This is only one solution for this equation. Okay, and this is a normal algebraic equation we are used to, and that makes a differential equation an equation. Actually, it has the normal structure of an equation. But the very important part here is uh, is is it being a differential. Well, the name implies that we have a derivatives here. Well, differential means derivative, so we can learn from its name only, that it is an equation that have derivatives, which is really the definition in very basic terms. So let me erase this. So the very first thing we need to know about differential equations is that it is only just an equation that contains a function and its derivatives, right? I'm assuming that you already have very basic knowledge of calculus, so you know what a derivative is actually, because differential equations is all about derivatives and integrals. So it's kind of a prerequisite for this course. So this is the definition we have here: an equation that contains a function and its derivatives. So we now know what a differential equation is actually. Let's see the types of differential equations. We have different types of differential equations. The very basic types are, let's say, ordinary differential equations, okay, which can be abbreviated for ODEs, and the other type is partial differential equation, which is PDEs. Okay, what can we learn from these terms or these names? Ordinary and partial. Ordinary and partial. Well, ordinary is just an ordinary differential equation. Ordinary differential equation, which means a differential equation that does not contain a partial derivatives. Okay, you know what a partial derivative is. So an ordinary differential equation is just a normal differential equation that does not have a partial derivative. And a partial derivative is a differential equation that contains a partial derivative. Easy to grasp, right? And we're gonna see examples. I just want you to know the definitions and uh, the types of the equation actually, and we're going to see examples of how an ordinary differential equation looks like, and also a partial differential equation looks like. So now we have ODEs and PDEs, partial differential equations, ordinary differential equations. Let's see also the order of a differential equation. For each differential equation, we have an order. Okay, what is an order of a differential equation actually? Well, an order of a differential equation is the highest present derivative in the equation. Okay, we already know that every derivative have an order or degree. Like we have the first derivative, let's say dx, sorry, dx dy. This as a first order derivative. This is the first derivative of x over y, right? And if we have the second derivative of it, it will be d 2x over dy 2, right? This is the second derivative, right? And so on, 3 and 4, etc. This represents the order of differential equation. Okay, so if we have 2 as the highest derivative in the equation, so it will be a second order differential equation, right? If we have the first order, it will be the first order, and so on. Okay, let's see an example to understand the concept. Let's see these examples right here. Well, let me just, okay, let's see these examples here. Well, the first equation is obviously a differential equation. So does the second equation, and so does the third equation. So all of these three equations are differential equations. Why are they differential equations? Yeah, because we have derivatives here. This is a derivative, this is a derivative, okay, and this is a derivative, and this is a derivative, and y prime here is a derivative as well. So these all are differential equations, right? So there's the first conclusion here that these equations are differential, right? What do we conclude also from here? We already know that there is difference between a partial differential equation, and an ordinary differential equation, right? We already said that a partial differential equation contains partial derivative, and an ordinary differential equation contains does not contain partial derivative, right? In this equation, do you see any partial derivative? Dy, dx, d4y, dx4. There is no partial derivative, right? So we can say it is an ODE, right? there is no partial derivative in here, so it's ordinary, right? In the second differential equation, we can see it's composed actually from it's composed of differential equations, partial derivatives. Sorry, partial derivatives, right? We have here partial derivative of z over x and z over y. So it is actually a p d e. And the last one is obviously an ODE because this the first derivative and it's not partial, and so it is actually an ODE. So now we have another conclusion. The first conclusion was that they're all differential equations because they have derivatives, and the second conclusion is that uh, is that the first one is an ODE because it does not have partial derivative, and the second is a PDE because it does have partial derivative, right? And the last one is an ordinary one for the same reason, right? The last thing we can conclude from these equations is that the first equation has an order, right? Every differential equation has an order, right? What is the order of the first equation? Well, we have to search for the highest derivative here. Do not consider exponents, okay? We're not concerned with exponents here. It does not affect the order of the differential equation. We are only concerned with the derivative. So as we see here, the highest derivative is 4, right? 4 is the highest derivative here. So we can conclude that it is from the fourth order. So this is an ordinary differential equation of the fourth order, right? And the second equation obviously is from the second order. This is the highest order of this is the highest derivative in the equation, so it is from the second order of a second order. It's a second order partial differential equation. Okay, and the last one actually this dash means that it is a first order or the first derivative, so it is actually a first order. So, in these three equations, we have concluded that the first equation is an ordinary differential equation of the fourth order, and the second is is a partial differential equation of the second order, and the last is an ordinary differential equation of the first order. We applied what we have learned before about types and orders of differential equation. Okay, and we can solve an example or let it for another video. Let it be for another video because it got so long. And that's all for now for this video. Thank you for watching. If you like it, consider liking the video and hitting the subscribe button. Thank you and good luck.